Hello everyone. Today I'm going to go over colligative properties. If you remember, we were talking about solutions before, and we mentioned that we have always one solvent and we can have more than one solute. And solutions are a homogeneous mixture that we don't see or we cannot tell where is the solute, where is the solvent. That's why we call homogeneous mixture. And in order to separate the component, we need to use distillation because we can evaporate, let's say, water and sugar. We can evaporate the water so we can separate both components. So today the topic will be on colligative properties, who are property that will change the vapor pressure, the boiling point, the freezing point, and also the osmotic pressure. And those properties will change based on the amount of solute you add, not the nature of the solute. For instance, the first one, vapor pressure. This is the pressure of the solution, and this is the pressure of the pure solvent. Always, when you prepare a solution, the final pressure, I mean the vapor pressure of that one, P1, will be less than the pure solvent vapor pressure. And the reason is because you are adding another substance that will compete with the solvent to go to the open air, to the atmosphere. And that's one of the reasons there is a lowering in vapor pressure. Let's put an example. If you have ethanol, which is an alcohol, and you add any solute to that solvent, it will be less volatile because the addition of the solute. The more solute you add, the less volatile will become the ethanol. So that's the first one. The second one is the boiling point elevation. You probably are familiar with this one because if you are cooking at home, you probably notice that when you add salt to the water, the temperature of the water, instead of start boiling at 100 Celsius degree, which is the boiling point for water, the water start boiling at higher than that. So the boiling point will increase. The formula is different in temperature. Delta T will be the increase in temperature for boiling point will be equal to the constant for boiling point elevation, and molality. Don't forget that molality is always mole of solute. So we can write here mole of solute, and the bottom part divide kilogram of solvent. Kilogram of solvent. And that will be the concentration that we'll use for boiling point elevation. For freezing point depression, that's another colligative property that we are familiar with, because when there is snow and the streets or highway or road freeze, the city adds salt to the road in order to melt the solid water, which is ice. And the reason is when you add a solute to, for instance, from water, the freezing point will go down. So instead of freezing at 0 Celsius degree, it will start freezing at lower temperature. When I say freezing, I refer going from liquid to solid. So the water will remain more liquid at lower temperature. And that's why this is the salt is added to the road when there is a snow in order to prevent, you know, accident, because you can slide on the road. So this is the delta T. Different in temperature always will be less than 0 Celsius in the case of water. Of course, we are mainly talking about water solution. And this is the constant that you will always given in a problem, or also you can find in a table. And again, this is molality. The fourth one is osmotic pressure. osmotic pressure is the pressure that the solvent is making against the semi-permeable wall in order um, to make two concentrations who are different equal. For instance, let's say we had, this is our semi-permeable uh, screen uh, or layer here. So the concentration 2, let's say, is greater than concentration 1. So what happens is the solvent, let's pretend it's water, will go out in order to make both concentration equal. So the osmotic pressure will be the pressure you need to do in order to avoid that, let's say, water will go out. So this is water coming out to the solution number 2. Let me give you a real life example of that. Sometime at home you are slicing tomato, it can be cucumber or onion, and if you are salt outside, after some time you will notice that the tomato or the onion or cucumber will become soggy because they start leaving some liquid from inside the tomato, the vegetable outside, to make the concentration equal, because the concentration outside by adding sodium chloride is greater than the concentration inside, and the liquid will try to travel outside to make equal the two concentration. Here we have the formula pi equal molarity. Now we have a different uh, form to express the concentration, gas constant, and T temperature in Kelvin. Let me remind you the molarity formula. Molarity will be equal to the number of mole of solute over the volume of solution. And the unit will be mole over liter. And that's the unit we use here in the expression for finding the pi, which is the osmotic pressure. This is it for today. We will keep working on some of the problems related to colligative property in our next video. Thank you for watching.